Oh, hello, good morning. Agnieszka, do you want to talk about the agenda or I do it?
You can if you prefer.
Okay, so good morning, everybody. I am Julen Astudillo from TECNALIA. I am the project coordinator of the AMALTEA project, and you can see now the agenda that we are going to have. Initially, we are going to have a fast introduction of what is the project. Then we are going to enter in a little more detail about the technologies that we are using in the project and the challenge that are the ones that are going to be used by external companies to the project to help us in the developments that we need to do. Also, in the third part of the agenda, we will talk about the pilots. We will give you detailed explanation of what are the pilots that we are going to have in the project. And then my colleagues of Funding Box are going to explain in the last part of the meeting how is the process of apply to these open calls, how is going to be the evaluation. And then in the last 20 minutes of the meeting, you will have the possibility to make questions, and we will try to answer the questions that you can make. Take into account that also, if you register in the proposal, as later is going to be explained, okay, we can have some conversations in order to let you understand what we are looking for. So next slide, please. So the project overview. AMALTEA project is an Horizon Europe project. It's a research project that has been funded by the European Commission. The idea is to use robotics, artificial intelligence, and data in the construction sector with some objectives, so reduce energy consumption, improve the use of resources, reduce the waste in the entire process, and enhance the safety and quality of the entire construction process with the objective of complying with the Green Deal objectives. Some key elements that we want to obtain in the project is to reduce energy use in the entire process that we are going to develop, reduce also the waste, and reduce also the defects. We put the defects in less than 1% in some processes that we are going to develop in the project. Also, as we are going to focus in construction sector, we want to improve safety and efficiency between 15-30%, reducing lower hours, and improve sustainability. So try to use as much as 95% of the components that we are going to process during the project, reusing or recycling them. As commented, we are going to validate the solutions in 4 European pilots. And the idea of these open calls that we are going to talk today is that we have around 25 small and medium companies that help us in some of the processes that we are going to develop in the project. The proposal focus on use robotics, artificial intelligence, and data in the curtain wall sector. So in the facade sector. And the idea is to improve the design, the manufacturing, the installation, and the disassembly and recycling, focus on facades. Next slide, please. We will explain a little later this. So what companies we have in the project? We have 15 companies that covers the entire value chains of the curtain wall sector. So we have companies related to the design, art, and etc. Digital, we have research centers and universities, TECNALIA, LORTEC, the University of Stuttgart. Robotics, we have companies like Robomatica, Siemens, Technopar, and also the research centers that are going to work in these processes. We have a facade manufacturing company in Hungary, FDB. We have 2 big construction companies, Acciona in Spain and Züblin in Germany, that are going to have some of the pilots that we have in the proposal. We are going to put a big effort in the social science and humanities with the Polytechnic University of Madrid, helping to involve the human also in the process of using robotics and artificial intelligence. And then we have companies like Fast Track and Digital for Planet to make exploitation and dissemination. And the company in charge of all these open calls is Funding Box. Next, please. Next. So we have, as commented, 15 partners. The project is going to last 48 months, so 4 years. It started on the 1st of January of this year and is going to last until December of 2028. And we have a budget for open calls of 4 million euros that is going to be split in two open calls. One that is going to start in August of this year, and the second will start at the end of the next year. So here you can see more or less the project overview, so which is the different topics that we are going to develop in the proposal. In the upper part, you can see what is the facade value chains, and we are going to focus in 4 main groups. The first group is related to the design, architectural design and engineering design. So how we can use different artificial intelligence tools to improve the work that is done in this part of the value chain. So how we can help architects and engineers to improve these processes. The second part of the project is going to be related to the manufacturing. So in construction, robotics and automation is not used a lot. So the idea is to improve different steps of the manufacturing of the curtain wall, introducing robotics and also using different tools in order to improve the quality and some of these processes that we are going to manufacture in the proposal. The third main group is going to be related to installation. So the idea is that we use some robotic cranes and robotic platforms to install these modules of curtain wall that at the end, the main problem that they have is that they are quite big. So you can see in the image in the center that we need to move modules that are around 4 meters height, 1 meter, 2 meters width, and can weigh around 300, 400 kilograms. So this is a big problem that we have in order to perform this activity, and the accuracy that we need for these movements is more or less millimeters. So at the end, this is a complicated process that we are going to develop in the project. And the last part of the works that we are going to do are related to disassembly and recycling. So we are going to use the same approach that we have in installations to uninstall the system. And also what we are going to do is using different equipment, classify the components of the curtain wall and reuse and recycle it, then base it also in the new design that we are going to propose that also need to take into account the future process that can be used for the facade or what can be how the components can be used later, etc., etc. You can see also in the picture the companies of the project and where they are going to work, but we will later explain this part. Next slide. Okay.
Thank you, Julian. Good morning again. I'm Anca Marin. I'm a project manager with Funding Box. And just very briefly, after this overview of the project from the project coordinator, Julian from TECNALIA, I want to emphasize the main objectives of this info day, which is a bit sooner than the open call launching. But we really wanted you to get a big preview of what's coming in August, and we really count on your insights in order for us to optimize and make this open call very understandable and reachable for you. So the main objectives today are, next slide please, Agnieszka. The main objectives today are for you to get an understanding of the project methodology, as briefly explained by Julian just now, for you to see the connection between the digital tools employed by the project consortium in this AMALTEA strategy, to understand the digital tools that are being employed within the project and how these digital tools relate to the pilots that we have in the project and the challenges that we are launching for you, the third parties, the companies, external companies to the project consortium, to work with both the tools and within the pilots. So we are trying to give you this entire image of how everything works together to create the AMALTEA ecosystem, the project partners, the technologies of the project, the methodology, the pilot, and your solutions. We hope with this info day, you will get all this information and you'll have a clear idea about what we are looking for and how you can be a good fit for one of the challenges or several of the challenges that we are going to launch in August. So I'm not going to take any more time for this one. As I mentioned, we're talking methodology, digital tools, challenges, and open call conditions. And I'll go back to Züblin. He's also a senior researcher with TECNALIA, and he will be the one giving us an overview of the methodology and the digital tools of AMALTEA.
So thank you, Anka. So the idea here is that we understand a little which is the methodology that we apply for this project. So, okay, as I have commented before, we are under the Green Deal approach. And what we are going to use is robotics, artificial intelligence in one sector in Europe, that is construction. So we need to comply with some key principles that are flexibility in all the activities that we are going to perform, integration. So the idea is to complement the different processes that we are going to follow, collaboration between humans and robots. The idea is to not completely automatize the entire process. The idea is to complement the robotics with human work. Sustainability is one of the key elements that we are going to improve during this process. The idea is to take into account sustainability across the entire value chains of the facade in order to improve it. And also innovation, because, okay, the idea is to include many different elements in a sector that is more traditional than the industrial sector, automation and other ones. Next, please. So in order to do that, what we have done in the proposal is to define 4 digital solutions. We have one digital solution for design, other one for manufacturing, other for installation, another for disassembly and recycling. And these digital solutions are going to have some digital tools that are going to be done by the project partners. Next, please. These digital tools are the work that is going to be done by the project partners, and these digital solutions and digital tools are going to be complemented by the challenge. The 8 challenges that we are going to show you later are the ones that you need to answer with your technology in order to help how we develop these 4 digital solutions. Next, please. So digital solution and digital tools is work of the AMALTEA consortium. Next. Open calls and challenge. The challenge are AMALTEA consortium with external companies. Next. So the digital solutions and the digital tools, we can see what are them. So for design, what we have a digital tool related to artificial intelligence enhancing parametric design, or automating the simulation for facade components, or having an extended digital twin of the facade design, manufacturing, installation, and recycling. If we talk about manufacturing, we have digital tools like artificial intelligence for manufacturing process optimization, automatic welding system, automated precision glass bonding with structural silicone, improve the quality control of the facade manufacturing. For installation, what we are going to need is digital tools that help us in mobile robotics platforms that are going to work in the on-site installation of the facades, or how we can improve the position, the control of these systems, also taking into account that we are going to have in a non-structured sector or a structured environment as is construction. Because of that, we are going to need some improvement in the sensors and the position of the system. And in relation to disassembly and recycling, what we have is this collaborative mobile robotic platform for the on-site installation and installation of the facades, and some automatic strategies for material sorting and recycling. Next. So, based on these digital tools and digital solutions, what we have proposed is these 8 challenges that now we are going to describe in more detail, because what you need to do is to understand the challenge, understand the proposal, and if you can propose something to make the challenge, you can apply to to the open call. So now next we are going to explain you challenge by challenge. Also, you will have the information of this available later, so it's not necessary that you copy all these things. So now my colleague Alex will explain the first one.
Hello, thank you, Julian, and good morning, everyone. My name is Alex Padoro from TECNALIA Artificial Intelligence team, and I am here to share with you the first challenge of this info day. As you can see in the slide, this first challenge is focused on data management and interoperability. We have divided the challenge in 5 different points to know about the problem, how we need to solve it, how we can test, and how we can measure it, etc. Why we need this challenge? As Julian has mentioned before, in this project, we are developing different digital tools. In this sense, the way we store, manage data, and establish the communications between the tools is a weak point in this process, because fragmented data, storage systems are not standardized. Data creates significant inefficiencies, limiting real-time data accessibility, collaboration, and effective use of digital twins. So to address this challenge, we need an integrated, robust, and scalable data storage solution that aligns with the project data management plan and the specific features of the different work packages. And we also need an standardized data and communication protocols framework or something to ensure seamless interoperability among diverse digital tools, and robotic systems and digital twins. Moreover, this solution will be tested in realistic construction scenarios involving complex facade installations, and with a lot of stakeholders, including architects, engineers, robotic operators, and quality inspectors, that all of them will need simultaneous data, access to standardized data, and integrate data. So the implementation of integrated data storage combined with standardized interoperability will significantly enhance efficiency, accuracy, and collaboration through the faculty life cycle. And it will be notably reduce data retrieval delays, improve decision-making processes, decrease data translations, errors, and shorten project timelines, and elevate overall quality. So this is the challenge: to sum up, the implementation of an integrated data storage and standardized interoperability is key to achieve the goal of the project, improving the efficiency and quality in the construction sector. And that's all. And thank you for your attention.
Thank you, Alice. Hello, everyone. My name is Markus Renner. I'm Research Associate at the Institute for Computational Design and Construction at the University of Stuttgart. Today, I have the pleasure to introduce you the second challenge, which is the previous slide, this one, called Parametric Solution Generator for AI Training. In order to enable facade design optimization using AI surrogate models, a comprehensive and well-structured dataset is prerequisite. Facade design is becoming more AI-driven, but a major challenge remains. While there's a lot of data available, the connection between design geometry and accurate material performance properties is still weak. This link is essential for reliable simulations and effective AI training. So coming to the challenge description, the goal of this challenge is to develop a parametric tool in Rhino Grasshopper that automates the integration of external parameters such as climate, location, and panel configuration based on building position with design geometries and material data. And the innovation lies in expanding current methods to support large-scale sample generation within the consortium's own infrastructure. And this includes delivering tools and workflows that allow iterative, reproducible, and scalable simulation runs. The solution will be tested in a collaborative environment across the consortium. The focus will be on usability, data quality, and how well the tool supports the AI trading workflows. From an industry perspective, the challenge will streamline the dataset creation process, enabling more advanced and sustainable AI-powered facade designs. We'll evaluate the solution based on usability, data completeness and accuracy, scalability of workflows, and compatibility with the consortium systems. And the success will be measured by generating at least 5,000 facade design iterations, each with performance data over a 9-month period. If there are no questions, then next slide, please. So let's move on to the third challenge, web-based graphical user interface for design decisions of platform-independent accessibility. So to enable effective use of AI in facade design, it is not enough to generate optimized results. We also need to make those results understandable and actionable for designers. The problem we are addressing is that AMALTEA already uses powerful multi-objective optimization and surrogate models to generate these design alternatives, but the complexity of these datasets can overwhelm users, so especially non-experts. And this limits the ability to balance aesthetics, performance, sustainability in the early stage design. The goal of this challenge is to develop a web-based platform-independent graphical user interface that makes AMALTEA's outputs interactive, intuitive, and accessible from any browser. So the innovation focus is twofold. So first, the visualization. The GUI should allow users to explore simulation results using tools like Pareto fronts and parallel coordinates plots. And second, AI-powered support. A retrieval augmented generation system will provide relevant data, similar past designs, and contextualized suggestions based on user queries, which is essentially turning raw data into usable insights. For testing, we simulate an early stage facade design environment where architects and engineers can test and evaluate alternatives in real time. We'll iteratively refine the interface and rank features based on their feedback. The expected impact for the industry will be that the tool will speed up decision-making, reduce iterations, and support sustainable and cost-effective outcomes. For small medium enterprises, it offers a lightweight browser-based solution that lowers the barrier to entry for advanced facade design exploration. The evaluation will focus on usability, clarity of visualizations, the relevance of rec outputs, platform accessibility, and responsiveness. And the success metrics include improved design speed and quality, more informed decisions, and positive user feedback. So in short, this challenge aims to bring the power of AMALTEA's optimization to users in a form they can actually engage with efficiently and intuitively. Thank you. Next slide, please.
Thank you, Marcus. I think we need to move on to Nerea.
Hello, good morning. My name is Nerea Verde. I work in TECNALIA also. And I work in robotics and computer vision and also 3D vision systems, developing the 3D vision systems. So here, this challenge is about advanced inspection and control system for quality assessment in robotic manufacturing. So in AMALTEA project, there are some offsite manufacturing of facades that have different processes, automatic processes that are mainly welding and glass bonding. So these processes are critical, and in this challenge, we need to do the quality inspection of both processes. There are normally done now by manually, and that these quality inspection are normally inefficient and time consuming and affects negatively to the productivity and safety. So we want to automate also this quality inspection system. The idea is to develop a system based on advanced sensors technologies like 3D vision system or cameras or whatever advanced sensor we need. And we also will then process this data with artificial intelligence, machine learning, or whatever to detect the defects that the process could provoke in the process of welding, and also to do the dimensional control, the defect detection, and whatever we need to do an efficient and to prevent then the defects. So there will be also some requirements from both process that we are going to define, and the idea is to detect with advanced sensoring and with artificial intelligence technology these defects of both processes. So the testing environment will be in a realistic manufacturing, typical of Facha's production lines, because these production lines have their own characteristics. They are very big facades and very big parts. So the idea is to test these systems in a realistic path. So we expect here to have some time reduction inspection quality system. We will eliminate defects proactively and elevate overall manufacturing productivity and reliability. So, and there will be also some evaluation criteria that includes the accuracy, the speed. It is important not to be a bottleneck part in this production line, this inspection quality system. So it's an important characteristic here. So whatever question you have, I can answer. Thank you.
So challenge 5 is also related to manufacturing. You will see later in the description of the pilot how is this manufacturing and in which points that we want to include this challenge. So, okay, which is the context of the challenge. So now traditional manufacturing, we have predefined shop drawings, and based on these drawings, new positioning of the different tools is needed. So at the end, this is something that limits flexibility if you need to use different facade geometries. Take into account that here we have one of the main difference with the car industry, that you have almost every time the same process. Here you can have 1,000 square meters of facade, but then you can have another 3,000 square meters of facade completely different from the previous one. So if you need to reshape completely the process, at the end it's impossible. So the idea is to make something that can adapt to the different facade geometries. So what is the description? Is to develop an adaptive manufacturing process capable of handling any panel geometry without requiring predefined CAD files or a strict position. The idea is to use computer vision and mesh generation to automatically generate the tool paths for welding and sealing, that are the two main processes that we are going to improve in this project. To do that, we are going to have FDB facilities that are placed in Budapest. Obviously, we can make tests in other facilities of the consortium. The idea is to test different geometries and check if the process that we have developed using vision systems, real-time mesh generation, robotic execution, can we validate the new activities of these automated systems with the different typologies of facades. The idea or the impact is to propose a solution that enables manufacturers to process custom designs without modifying production lines or generating new templates. So at the end, we are going to reduce time, cost, when we have a small amount of facades, so we cannot use we cannot use, or we can use only this system when we have a very big amount of square meters, but not where we have small amounts. The idea is to have this type of flexibility. And the evaluation criteria is going to be, okay, if we are able to recognize the geometries, generate the paths, and the integration also with the previous challenge related to the quality assurance process. Okay, at the end, it will be measured. Also, we will measure depending on the amount of panels that are produced without the need for shop-top drawings, and also the reduction in time and in the reduction in the entire process. This is more or less the idea that you are going to understand better once we saw the description of the pilot. So next challenge.
Hello, I'm Eduardo Chamorro, part of TECNALIA's team of Materials and Industrialized Systems. Here we are presenting two challenges that are closely interrelated. It's challenge 6 and 7, and they will work as a unified solution for the construction pilot sites that they are related to the robotic platform and how it allocates and installs the facade panel on the construction site. Challenge 6 focus on the base that construction environments are messy and irregular, far from clean and controlled spaces where most of robots are used to work with. In our case, our robot needs to see and understand the environment, the construction site. Basically, it will be on a second or third floor probably. And it will use these 3D lidars, stereo depth cameras, and total station and reference prism to locate itself. So we are looking for a real-time sensor fusion solution that can combine all this data into a single high-quality 3D point cloud with higher and lower densities in certain areas, depending on where we point and we want to focus the action. All this should happen while the robot is in motion. This point cloud should not only reflect the environment with high detail and high accuracy, but also implement algorithms for segmentation masking to help the robot recognize subjects like support or panels where actually the facade panel will be anchored, as well as visual markers such as April tags. The challenges focus on the combination of different densities of this visual data, all referenced within the mark of a total station inputs to generate a RGB point cloud that is precisely referenced to the real construction site, not just a pure digital model. That means we are aiming for higher accuracy, have a better database and for obstacle detection and a smoother autonomous navigation. The solution is expected to be tested in lab conditions that simulate the construction environment as further integration in the final construction site and should deliver a sub-centimeter accuracy for object detection to help us foster proper measurements and safe movement within these kind of environments. We are looking for a reliable ROS-compatible system with an open architecture that has a sensor calibration setup routines that makes the process seamlessly, and accurate object recognition, and with a robust point cloud fusion that unifies all the data in one single element. On the other hand, challenge 7, please, Anka. And these challenges, we are talking about autonomous navigation of intelligent machines that can navigate through these environments. These unpredictable spaces where not fixed landmarks are set up, there is no GPS signals, and definitely no clean lines, and straight path of motion can be run for these AGV platforms. Right now, most of the 3D navigation systems can really cope with this kind of settings, and they are too limited or not precise enough to navigate with this kind of unstructured environments. That means that they struggle to move safely and independently, especially when there are humans operations involved next and surrounding them. We are calling for solutions that can deliver advanced 3D localization within our live point cloud creation and for these navigations. So as I mentioned before, ideally challenge 6 and 7 will be further integration, but we have split them between the higher and more refined point cloud and one that focuses more on the navigation, that is this challenge 7. We want something that builds in live, up-to-date 3D map on the environment and is used to guide the robot in real time. This includes path planning, detecting obstacles, and avoiding collisions all on the fly. This solution should combine a smart sensor and preventing AI navigation for dynamic position of the platform in these unstructured spaces. We want to have a human-machine interface that is friendly and runs straight away from the robotic servers and can deploy to have an easy interface with the robotic platform that we plan to use for the pilot size. As well, this solution will be taken in TECNALIA's probably facilities for preventing navigation testing map, and then we will run as well on the construction site. In terms of the challenges, this challenge has potential to push the boundaries of autonomous constructions, and we want to evaluate these proposals on several facts. One of them, can the robot move autonomously and safely through a 3D mapped space? Can a non-technical user operate it through with a nice and friendly interface? And can the system have the navigation within a point cloud and digital map with a high accuracy of minus 5mm precision, even with these rough conditions? And this is more or less the sum up of these two challenges.
Okay, now the last challenge is related to how we can enhance the life cycle and cost assessment through artificial intelligence and smart data integration. So, as you know, LCA and LCC assessments are sometimes complex because of the limit data that we have on the fragmented data. So sometimes it's complicated to collect all this information. There are many different databases. It's complex to introduce these processes in the process of manufacturing and to collect the data from there. And some sustainable materials and construction techniques are poorly represented in conventional databases. The idea is to use this, not use only a collection of data from databases, but also to use artificial intelligence to extract this data and make analytics of new ways to close gaps and enhance how we can make this assessment. The idea is to evaluate the challenge. The description is evaluate the environmental impact and cost of the complete facade value chains in AMALTEA. So we need to focus on the process that we are going to develop from the design, from manufacturing, and from installation in order to see how we can collect this data, use this data, and extract knowledge of the way that we are doing the process. The idea is to have an intelligent, user-friendly tool that can automatize this process in different ways, and also have some predictive modeling that can give us more information of where we are in terms of sustainability across the entire value chains of the facade, to allow us to change some of these processes in order to improve them or to have different approaches. The idea of the pilot and testing environment is to use the real data that we are going to have in the project. So, because as you know, as you have seen, we are going to have a manufacturing facility. We are going to make installation of these systems in real buildings and laboratories. And also the idea is to uninstall some of them and process the products and components to see how we are able to use all this information. The idea or the impact is to support manufacturers and construction stakeholders in order to make the data-driven sustainable decisions and reduce waste and energy in the entire process of the value chains. Also, something that I haven't commented is cost is something that is quite important to be introduced in this equation to obtain data about how different decisions affect the final cost of the facade. For the SME benefits is make easy tools to be used and that can help construction companies based on the activities of these SMEs to improve the activity and the data that we obtain from these processes. The evaluation, at the end, as we are going to have these elements in contact with real scenarios, the idea will to see how we collect this data, how analyze the data, which are the information that we obtain this data, and the idea is to improve circular economy practice and enhancing environmental performance of the entire life cycle process of a facade. So more or less, this is the 8th challenge. Next. So related to the pilots, next, now what we are going to do is to show you which are the 4, in more detail, which are the 4 pilots that we have in the project. We have 3 physical pilots and 1 digital. The digital is the one related to the design and the extended digital twin with all the data that we are going to need from the different process to do that. Then this is the digital. Then we have the 3 physical. So we have the pilot 2, that is the facade manufacturing line in FDB facilities in Hungary, in Budapest. And the pilot 3 and 4 are going to be 2 real construction scenarios with different building types. In the south of Europe, I still is not sure where we are going to have this pilot, in Portugal or Spain. We are going to talk about more residential, hospital buildings. And in the center of Europe, that probably now we are looking or analyzing a building in Stuttgart, in Austria, in Vienna, is going to be an office tertiary building. The ones that we are going to use. One thing that we need to know about the pilots is that the idea is to enter in the construction. In the case of the pilot 3 and 4, we are going to enter during 1 month or something like that, in order to make our tests, make the installation of the facade with the process that we have developed, but then remove everything. So we are not going to need to comply with the final regulations that are needed in construction in order to improve the processes. I have seen that there are some questions related to TRL. We are going to finish the project with a TRL around 6. So the idea is to have the pilot tested in real environment, but not in a commercial way. And the idea is also that these open calls help us to improve a specific part of these pilots with the different activities that we have mentioned in the challenge. Next slide. Marcus.
Okay, thank you, Evelyn. Let's begin with the first pilot, which focuses on design phase innovation, specifically AI-enhanced facade design. The first pilot is all about validating AMALTEA's parametric design system and the associated extended digital twin environment. Together, these technologies allow designers to generate, evaluate, and optimize curtain wall facade panels guided by real-world constraints and goals. The image on this slide illustrates 2 key aspects of the design phase. So on the left, you see various facade panel typologies generated parametrically, which we already studied. And these panels are then evaluated through the process shown on the right, like a workflow diagram that maps how user input, performance simulations, and AI-driven optimization are integrated into a single streamlined design tool. And the design pilot acts as a sandbox environment for architects and engineers, where a selected reference building, either conceptual or from a partner's portfolio, has to be decided and provides realistic constraints, including structural loads, performance targets, aesthetic goals, and regulatory compliance. Although the design setting is virtual, it's grounded in a practical real-world constraint, ensuring that outputs are truly implementable in later stages like fabrication and construction. Next slide, please. And the pilot 1 explores how AI and digital twin technologies can enhance and streamline the early stages of facade design. The process starts with designing input key constraints like aesthetic goals, energy targets, and construction requirements into the parametric model. From there, the AI optimization engine runs thousands of permutations, applying embedded simulation modules, evaluating thermal, structural, environmental, and cost performance. All this is dynamically captured by the extended digital twin, which acts as a living data container, linking each design option to materials, lifecycle data, and manufacturing logic. With the Apollo protocol or a similar integration standard, the data flows smoothly between design, manufacturing, and construction systems, ensuring the interoperability and traceability. Next slide, please. The overarching goal of Pilot 1 is to build an AI-augmented design platform that links sustainability goals with efficiency and usability. The system integrates surrogate modeling techniques, fast approximations that reduce simulation time, and multi-objective optimization algorithms that evaluate trade-offs like cost versus comfort or material usage versus carbon footprint, for example. This allows design teams to explore a wide range of viable solutions automatically and with more confidence in the data behind each one. Ultimately, the aim is to accelerate sustainable design without sacrificing depth, detail, or regulatory compliance. Next slide, please. So we're using this pilot to evaluate not just technical performance, but also usability, interoperability, and impact. That includes how well the AI tool generates feasible, high-performing facades, reduces time and effort, supports multi-objective exploration, and integrates with downstream systems like BIM and manufacturing tools. And lastly, the design pilot is about proving that the system enables smarter, faster design, drives transparency across the life cycle, and supports adaptable, sustainable architecture aligned with circular economic goals. Next slide, please.
I think that you passed one slide, Agnieszka, the previous one. Yes, now we are going to talk about the manufacturing pilot. So the idea is to improve the manufacturing line of curtain wall facade process. FDB facilities are located in Budapest, in Hungary. As commented before, okay, we are going to be able to make some tests in the laboratories of the different partners of the consortium, but the idea is at the end of the project, so we are talking 2.5 years from now, is to have this manufacturing line working with the activities developed in the project in some specific points of the curtain wall manufacturing process. The idea is to transition to semi-automated and artificial intelligence supported manufacturing, taking into account that at this moment, apart from some Japanese and Chinese companies, the manufacturing of facade modules is being done mainly manual. So you have a manufacturing line similar to the one of a car. Is a linear manufacturing, but as the processes are quite complex and as commented before, are quite different for a small amount of facades. So we are not talking about producing 1 million of cars. We are talking about producing 500 modules of facade, or 300, or 200, or 1,000. So we are not talking about a big amount of components. So the idea is to introduce semi-automation in this manufacturing process without reducing or without eliminating the human that is going to help in some of the process that also are going to be quite complicated to be done by automatic components. So as key innovation of this manufacturing line, what we want is to use some cobots, collaborative robots, in order to help the human to perform complex assembly tasks. We are going to focus in the project. So now the curtain walls, the connection between the different elements is being made using screws and this type of connectors. The idea is to use welding to replace these screws and have better recyclability later in the process, improve thermal behavior, reducing air gaps and water entrance because of the connection between the different profiles sometimes has this type of problems. Also, facade manufacturing has huge problems related to quality because many things sometimes happen that are different once you install them to the one that you have designed. So the idea is to improve the quality assessment of the process when we talk about this welding connection and when we talk about this silicon for the support of glass application. Now there is a visual inspection. The idea is to use robotics for welding and robotics for this structural silicon application, but also, as commented in also some of the challenge, improve the quality of the entire process using automatic tools to check if we have any fails during the process. The idea is to use real-time computer vision for improve this quality control. And also what we need is to have some collaboration between the humans and the robots and also reduce the safety problems that we can have because we are moving elements that are quite big and weight, and sometimes these are that imply some problems. So what are the pilot objectives? Is both production through throughput and quality. So the idea is to make more modules per hour, improving the quality that we have at the end of the manufacturing line, improve the worker safety and ergonomics, reducing the movement of big weights and be in not very good places. Also, something related to sustainability is going to be part of this process. The idea is to reduce material waste and improve the environmental or reduce the environmental impact of the entire process. So the idea is to check what are the values that we obtain with the different approaches that we are going to test here, and later demonstrate scalability of this digital manufacturing and the real-world scenarios, as commented with the FDB facilities manufacturing that we are going to use in the process. An example or the approach, next slide please, of the approach that we have. This is something that you can see here. So in the upper part of the image, you can see a module with the humans, with the different steps that we have for the manufacturing of the final module. So we start assembling the profiles. Then the idea is to weld the connection between these profiles in the corners using this extractor in yellow, something similar to that, where we are going to have a robotic end effector that is going to make the welding that are going to be placed in the connection of these different profiles, take into account that the usual profiles that we have in the curtain wall sector are aluminium and steel. So we are checking what are the best approach to perform these welding activities, in which material, which is the one that provides more benefits and less problems. Also, continuing with the process, you can see that there are some insulation that need to be placed in the curtain wall, mainly in the part that is going to cover the slabs of the building. This part initially we are going to do in a manual or human mode. The insulation is not very heavy, so this is something that can be done with not a lot of problems. But then we start with the next process that we want to automatize, that is the placement of the glass, taking into account that the glass usually covers the entire front of the curtain wall. So we are talking about glasses with 4 meters by 2 meters dimension. And this glass is connected to the profiles with a structural silicon that avoids that this glass can fall down during the life of the building. And this application of silicon at this moment is being made manually. with some problems because of defects, because of you stop the work, or because you continue or you don't perform the work in the similar way that you have done in the previous moment. So the idea is to use a similar end effector to the welding with a different head in order to put the welding in the connection between the glass and the profiles. Then the next step will be to install the final accessories that are going to connect the curtain wall to the building. This is something that is going to be done by humans. And the last process, at least this is an image of the proposal, the last process, but this is something that probably needs to be done after the welding, after the insulation, after the sealing. What we need to perform is a quality control that this quality control is going to be connected to the module that we have in the digital twin, and we will have some information in this digital twin that is going to tell us, okay, the different components of the curtain wall have been placed properly, but also we need to make a visual or camera inspection of the final system to check that we have small defects that are going to be tested during the process, what can be accepted, what cannot be, in order to final the process with the level of quality that we want for this entire manufacturing process. And the idea is also to improve, so not need 2 days to manufacturing one model. The idea is to improve the time, reduce the cost, and improve the quality of the entire process using this automatic system. So next slide.
Okay, good morning, everyone. My name is Álvaro Flores. I'm the R&D director at Robomatica. Once you were introduced the project overview, all the challenge and the first 2 pilots, I will provide more context about AMALTEA's installation work package, which aims to change how we build Europe, the robotic installation of facade panels. This will include pilots 3 and 4. But first of all, let me introduce the technical team that is involved in this mission. It has been mentioned before. I would like to get it a bit deeper. This includes TECNALIA, the Polytechnic University of Madrid, the University of Stuttgart, Siemens, Envolventes Arquitectónicas, Tecnopar, etc. Solution, and us, Robomatica. In addition, we are not developing the technology in isolation. We are working with 2 industry partners with whom we will test our innovations in real conditions. These are Acciona, a global leader in sustainable infrastructure and renewable energy projects, which brings practical experience from complex construction projects, and Züblin, known for excellence in construction and engineering services, which will provide the quality standards and precision that define modern European construction. These partners provide essential real-world validation to ensure our innovation work in practice. Now, let me paint the picture of the challenge we are solving. Imagine a construction worker suspended high above the ground, manually positioning heavy facade panels in wind and weather. Every movement carries risk, every measurement must be perfect, and every installation takes precious time. The challenge we are addressing in this work package is transforming this dangerous and sometimes inefficient process through robotic installation of the facades panel. This involves 2 critical operations that must work in perfect harmony. Anchor installation, where mounting points must be positioned with high precision, and facade module installation, where panels weighing hundreds of kilograms must be placed with absolute accuracy. Our pilot sites aren't laboratory environments with control conditions. We will be testing or develop technology under real construction conditions where Murphy's Law rules and everything that can go wrong often does. Weather changes, schedule shift, material arrives late, equipment breaks down. These are the conditions where our technology must prove itself. Through our pilots, we will be measuring in 3 dimensions that matter. First, we will validate our installation simulation and planning workflows, proving that our digital planning tools can predict and prevent problems before they happen. Second, we will be testing our disassembly and end-of-life strategies, because truly sustainable construction means thinking about the entire life cycle from day one. Third, we are creating on-site performance monitoring and feedback loops, building systems that learn from every installation and get smarter over time. We want to prove that our solutions work across the diverse landscape of European construction, and that's why we consider different European areas and construction needs for the pilot selection. Let me provide some more details over the brief introduction made by Züblin. Our first pilot will be in Southern Europe, probably in Spain or Portugal, and will focus on a hospital or residential building with Acciona. The building must deliver energy efficiency and sustainability while providing natural lighting and thermal comfort. We will be working with curtain walls, steel and aluminum panels, and glass facades. Our goal is ambitious: validate digital tools in health-sensitive and time-critical environments. Our second pilot is in Central Europe, probably Austria, featuring office or residential building with Züblin. This represents the future of European urban development, where building must serve multiple functions while meeting the highest energy performance standards. Aesthetics excellent and daylight optimization aren't luxuries here, they are requirements. We are working with advanced curtain walls, incorporating composite and metallic panels, and our goal is to demonstrate that AMALTEA's modular digital solutions can adapt to the sophisticated demands of modern European architecture. The difference between these pilots tells the story of European construction diversity. We are dealing with southern versus continental climates, different functions and speed versus aesthetic priorities. Different regulatory environments across Europe demand different approaches, but our technology must work everywhere. This strategic selection will prove something crucial, that our solution has true transferability and European dimension. Next slide, Agnieszka, please. Let me walk you through what we are building using this system overview. Looking at the higher part of this diagram, we can see two core steps in the installation process. First, digitalization and mapping of construction environments. Unlike factories, construction sites are dynamic and chaotic, with limited reference points for robotic navigation. We are creating real-time digital models that give our robots the spatial intelligence and accuracy they need. Second, precision anchor installation using robotic platforms integrated with high accuracy positioning systems. On the two lower floors, we can see the robotic coordination module installation task. We are creating a symphony of automated systems working together. The spider crane we can see will provide lifting capacity and course positioning. The mobile robotic platform will deliver precision guidance with robotic arms, vacuum lifters, cameras, lidars, and different sensors. And the magic happens in their integration. The crane will handle heavy lifting while the platform ensures perfect alignment and installation. The AMALTEA project aims to make meaningful improvements to facade installation process. We are working to reimagine how this can be done more safely and efficiently. This challenge requires innovative thinking and diverse expertise, and this is why we are encouraging innovative SMEs to join us through our open calls. Whether your expertise lies in robotics, sensors, AI, construction technology, or digital solutions, there might be opportunities for collaboration in AMALTEA. Together, we can work towards more sustainable, efficient, and safe building practices. We believe this transformation is possible, and we are looking for partners who want to be part of making it happen. Thank you for your attention, and I would be happy to discuss potential collaboration opportunities.
Okay, and the last pilot is related to dismantling and recycling. So the idea, and this is something that we are going to see later in the scheme, is how we can make, using the approach that we have in the previous pilot, so that we are going to use robotic and automatic platforms in order to uninstall the facade modules. So how we can improve this process of reusing a facade that is not longer used in a building. So the idea, we can see here 4 steps. So which is the material condition that we have in some building. So the idea is to automate the inspection using different sensors after the removal of the facade to see, okay, which is the status. This is something that can be reused, or at the end we need to recycling it, and which can be the characteristics of the material in order to follow one of these two steps. The idea is to obtain real-time conditions about which is the status of the different components, collect this information, and use it using these new artificial intelligence tools in order to improve the entire process. In relation to the reuse and recycling framework, the idea is to, use some of these tools, but also we need to combine them with the expert validation. So this is another point of the project where we need the human, so we cannot leave the entire process to be done by an artificial intelligence, because at the end we are going to have many fails, and this process cannot fail in any moment. So the idea is to use these artificial intelligence tools to improve the way that the expert assessed the process, but with the expert, not removing from the equation. The idea will be to make decisions based on the integrity of the different components, possibilities of reusing the different materials, and later compliance with the regulations that is going to be needed for different components in the reuse activities. As commented, the idea is to have this human-robot interaction. Also, during the process, it's going to be quite important to define safety zones and emergency and stop system. This is going to be something combined with the previous pilot, where we are going to define many things in relation to safety, and also check how we can comply with construction regulations that have some requirements here. The idea in some cases is to use remote interfaces and train the operators in order to improve the process without compromising the safety of the different activities. So as conclusion of this part is the idea is to have a safe, intuitive collaboration between humans and machine. And the expected outcome that we are going to have in this process is a smarter disassembly that improves circularity and that is aligned also with the AMALTEA digital and sustainability goals that are more or less based on the Green Deal principles. Next slide. Here you can see the scheme of the process that we have in the proposal phase. So as you can see, the idea is to dismantle the facade using the same process that we have used for install the facade. Obviously, this is going to be the approach that we are going to have in the project. Probably in real scenarios, we are going to make some difference to this process depending on the conditions of the building and the possibilities that we have to include this type of systems. Then we are going to have a part where the human is going to enter in the disassembly of the different panels, taking into account that one thing that we have good in this project is that we choose a product that is semi-industrialized. So we are talking about glass, aluminium, steel, gaskets, silicone, polyamides, these type of materials. So we are not talking about concrete, bricks, gypsum, of this type of components that sometimes are more complicated to be evaluated. So more or less, apart from the glass, almost all the components maintain their characteristics during the process, and are materials that behaves quite good in terms of time in the buildings that they have been placed. And the idea, once we have the components disassembly, is to classify and sort the materials. Here we are going to have some additional developments that some partners have in relation to how we can classify in a semi-automatic way these materials. There is a product that TECNALIA has, that the name is Tracia, that is used for classify different materials using a range, a big amount of sensors that can detect, okay, which are the characteristics of these materials, what are they made, what are their status, and what are their possibilities, and also connecting this information with the digital twin and the activities that we have performed in relation to the design, that also they are going to take into account the possibilities of how we can reuse these materials in other components. I am talking about furniture, another different type of facades or different type of components that can be used in construction. So the idea is to classify the components using these different sensors and then establish path of reuse and recycling of the different components in order to be used and complement and improve the circularity of the entire process. So more or less, this is the final pilot that we have, or a complement pilot that we have for the activities that we are going to do in the other three pilots that has been commented. And now, Anka, I think that we are going to talk a little more about what are the structure of the open calls.
Yes, we are. Thank you, Julian. Thank you, everyone, for your contributions. And we hope you got a bit of understanding about the challenges and the pilots and the digital tools of AMALTEA. Now, regarding the first open call that we are preparing for the 20th of August to launch this summer, towards the end of the summer. So the main point here for the first open call, you have heard, we have already shared, AMALTEA has a budget of 4 million euros to distribute to third parties. And for the first open call, we are looking to select up to 10 companies, SMEs and startups from Europe and associated countries to Horizon Europe to join our support program. The first call will include a mix of both software and hardware solutions, and the maximum funding will be up to 100,000 euros for software solutions, while for the hardware solutions, the beneficiaries, the selected companies, will get up to 200,000 euros to deploy and test their solutions within the AMALTEA pilots. So as you can see here, a sketch of the timeline with respects to the open call is launching on the 20th of August. We have organized this info day prior to that in order to have this opportunity to share the technical parts of the projects with all of you. We'll share contact details. So if you have other questions or comments or suggestions, or something is unclear for you at this point, we'd actually benefit from your input, your feedback today, so that we can make it clearer in the documents, in the open call documents. But before that, I would also want to announce that we are going to have two other webinars during the open calls. One will be in September and the other one will be in October. And in these webinars, we are going to dive deeper into the aspects of eligibility and proposal writing for the open call. The process, as you can see it here, will continue after the call ends on the 30th of October. We'll continue with the evaluation stages. And in the AMALTEA project, we also have the final step of selection is a jury day. So pre-selected companies, pre-selected beneficiaries will be invited to pitch their ideas in front of the project consortium, and the top 10 best proposals will be selected to join the program. We estimate that to happen around the beginning of March next year. The software solutions will join a 9-month support program with mentoring and business support from the project partners, while the hardware solutions will be with us for 12 months. So we estimate that the first support programs will end around November 2026 and February 2027 for both software and hardware solutions. Next slide, please. Okay. We encourage applicants to have a very good look at the information regarding the open call, and will be, once with the launch of the application form online, you'll have the opportunity to go through all the materials, not just what is shared today, but also the guide for applicants and some technical guidelines for you to get an overview of everything that we have commented today and more. So we encourage you to apply, because this is an opportunity for tech providers, for tech solution companies to develop cutting-edge digital and robotic solutions for facade applications. We are in the construction sector with a special focus on facade. We would like these selected applicants to validate in full-scale industrial and construction pilots across Europe, the 4 pilots that you've heard about earlier. The selected applicants will get access to the ecosystem of industry leaders, research institutions, and other relevant platforms. As you might have seen here today, some of the partners that are forming the AMALTEA-project come from very diverse backgrounds and wealth of knowledge and experience. Also, you would be receiving mentoring, as I mentioned, for the tech development during the support program, as well as business support, and you'll be contributing to the EU Green Deal objectives through sustainable building innovations. Construction is a sector that has been traditionally mainly manual, so it is a sector that has been left behind in terms of automatization and technological development, and this is our effort to make a change for this fragmented sector. Next slide, please. As mentioned, the 10 selected applicants, the 10 selected companies will be offering both software and hardware solutions. We are looking for individual applications from companies. We are not looking for teams of SMEs and startups, just individual application from SMEs and startups. I think there was a question about that. And these, the selected ones, the beneficiaries will get up to 100,000 euros or 200,000 euros, as mentioned before. The key areas that are related to the challenges, the 8 challenges that have been presented today, and the 4 pilots that contribute to the AMALTEA ecosystem, come from integration of AI in design, data interoperability, quality control in manufacturing, training for installation and control, safety and life cycle assessment. While for hardware, we also have a focus on inspection and quality control in manufacturing, on-site installation, dismantling, and recycling. These are all related to the 8 challenges that we presented before, and we expect applicants to look at these challenges and submit an application or 2 for 1 individual challenge each application. Next slide. So another question that I've seen in the chat before is regarding TRL. We expect participants in this open call to start from a TRL of minimum 3, which is a experimental proof of concept. So this is the minimum TRL that solutions coming from eligible applicants are expected to onboard with, and throughout the support program, they should develop, and actually it's a condition, so they must develop to a TRL of minimum 6. These are the steps of the deployment of the solutions within the AMALTEA ecosystem. For the 9-month support program, we will start with the proof of concept, TRL 3, and then develop towards the alpha version and have it tested and integrated in the pilots. For the hardware solutions, there's a 12-month support program, and we're starting from the same TRL, prototype, proof of concept, and we are going through the 3 stages of execution that would end up with the prototype being tested and integrated in the partners' solutions. So for both funding instruments, We follow the same structure in terms of development and payments, as you will see later. And the TRL, entry TRL has to be 3, while we expect the exit TRL to be around 6 or 7. Next slide, please. Regarding the eligibility of the applicants, I've mentioned that we are looking for a total of 25 SMEs in 2 open calls. So for the first open call, we are focusing on selecting 10 SMEs. They can be include also startups. They have to be registered. I believe some of you are familiar with cascade funding with financial support to third parties. So the conditions are to be registered as a small or medium enterprise or startup in EU member states or Horizon Europe associated countries. Now that you have got an understanding of the digital tools of AMALTEA, there you can understand whether there is an alignment, a technical alignment between the technologies that you are offering as a company, as a technical company, and the digital toolbox from AMALTEA. There is another condition that we have included from the topic, from the European Commission topic, which is the capacity to finance, to co-finance 30% of the project. That means that for maximum financing of 100,000 euros, for example, the total budget of the project should be around 140,000 euros. So we are working with a lump sum mechanism. This means that you do not have to provide documentation regarding expenses. We do not ask for timesheets or contracts or invoices. Payments are being made against deliverables, but it is important to consider that for a maximum funding, there is a total budget that has to be co-financed with a 30% by yourselves. In our perception, in our understanding, but this is not a limited list, this is not an exhaustive condition, the type of applicants that we are looking may come from the deep tech and AI-driven companies, tech providers for the construction sector, digital twin and robotics innovators, and pretty much companies, technical companies that deal with technologies in smart building, digital twins, robotics, automation, computer vision, human-machine interfaces. This, as mentioned, this is not a condition, it's a list that we have thought of, but we are going to look at other profiles as well, as long as there is an alignment with the project objectives at the technical side and they comply with the eligibility condition of being an SME or a startup. Next slide, please. I mentioned the lump sum mechanism, which is a flexible way of beneficiaries getting the funding. And for both funding instruments, both for software and hardware, we have included 3 stages of execution accompanied by 3 tranches of payment. As you can see here, for the 9-month support program, there will be an initial payment once the individual mentoring plan is approved, just the first month into the project. And then for stages 2 and 3, there will be other deliverables to be submitted at certain times and be validated by the project consortium. And their positive validation will entail the transfer of the 2nd and 3rd tranches of payment for both software and hardware. I'm not going into too many details of the application process because the call is not launched yet. And as I mentioned, there are going to be 2 webinars that are going to focus on the application process itself. The idea of the Info Day today was to get this understanding of the technology components of the project. And I am very happy to see that there are quite a few questions regarding the challenges and the pilots. And I would jump right into that if you don't have other comments, Julian or Alvaro, Eduardo. No? Okay. So first of all, there's been, I think there were questions related to the availability of the slides and the recording. Yes, we are going to make these resources available for everyone. You are going to be receiving information as soon as the call launches. and you are going to get access to the microsite where you can apply directly on the Funding Box platform. You can also follow us on LinkedIn. I will share the links in the chat, and contact us through the help desk or the contact form on the project website. These were a couple of questions that we got in the chat earlier, administrative stuff, and now we'll just go to the questions in the order that I've seen them from the beginning of the presentations to now. Some of them have been addressed in the chat, but I'm going to start with the first one that was mentioned there, and that is a project that has as its end user a dairy company wishing to automate the production process of interest to them through the use of robotics and AI. Is this too far off the target for an application to AMALTEA? So my understanding is that we are talking about a dairy company with, if the person posing the question is still here, they can unmute themselves and contribute more to the question. So, Julian, I don't know if you want to take this or I should answer it.
My understanding is that if you are talking about you are talking about milk production.
Dairy company, yes, a dairy company. So
It's a little far of, as you have commented, it's a little far of what we are looking. The other thing is that, okay, you can have processes that can have been done for other sectors that can be used here. This is something that is open. So if the sector of your company is the manufacturing of food, perhaps there is some process that can be used, taking into account the requirements and the challenge that we have commented. If you can apply this type of technology to what we are requesting, nothing happens if you come from this food sector or industry sector or whatever. No problem.
Exactly. So if there is a technological component to this business that could be applicable to the AMALTEA technologies, then yes, it could be an applicant. If you are thinking just in terms of applying AI or robotic solutions to your dairy business, then this would be more like a use case or one of our pilots, and we are not financing that.
Take into account that the problem that we have is that many of the technologies that we have commented are not applying to construction at this moment. So, from my understanding, in many cases, what is going to happen is that technologies that are being used in other sectors, because of your knowledge, you can consider, okay, I can give an answer to this request that they have. And obviously, probably we will need to make some adaptation of the technology to our request, but this is something that is part of the project. So I don't see any issue. In fact, from my understanding, probably it could happen that many of these 25 companies are not connected to construction at this moment. They are going to be connected because of the process that we are going to develop.
Okay, moving on to the next question. It is more related to the human-robot interaction, and I believe Professor Gamboa, who is one of the project partners with the University of Madrid. How do you expect human to be involved in the process in collaboration with automation solutions? This question was addressed in the chat. If there is a follow-up question to it, we can take it live now. Okay. There was a question regarding challenge 2, if there are datasets available for challenge 2, or do we need to create ones? And Marcus unfortunately had to go before the info day ends, so he left the answer in the chat as well. We'll move to challenge 5, where we have another question. Is it restricted to welding and sealing, or can we focus on assembly and nailing a facade? Can we test in a local company instead of location in Budapest? This is for challenge 5, Julian and Eduardo.
Yes. Okay. What we are looking for more is more related to welding and sealing, but we are open to other components of the facade because this process is going to be quite complex. So if you have a solution that can be used for this assembly part, my understanding is that you can make the proposal. And then the last part of your question, that is if we can make the test in a local company instead of the location in Budapest, is what I have commented before. You can make some of the tests in your facilities, but the idea and also part of the funding can be used for that is that we implement the solutions in FDB facilities to test that what we are proposing are aligned with the result of the project. Take into account that the idea of the challenge is to complement the main objectives of the project, and the main objectives are the activities related to design using artificial intelligence, the improvement of the manufacturing process, the improvement of the installation process, and the improvement of the recycling processes. What we have in the challenge are specific steps or specific elements that are going to help us to improve these 4 main activities that we have in the project. And because of that, at the end, we need to implement these solutions in the final demos. The way that we are going to implement, this is something that we can comment and discuss, and perhaps you can submit us the technology. We can make some tests in the final demo, and it's not necessary that many of you go to Hungary in order to make the final testing. This is something that we can see. It's not close.
Okay, thank you, Julian. What is the expected TRL at the end of the project? Is it the same for each challenge? I mentioned that throughout the presentation for the open call eligibility conditions. So the TRL at the end of the support program must be a minimum 6. This is a condition. TRL 6 means that the technology is demonstrated in a relevant environment, and this is the whole point of the AMALTEA consortium, offering on the one side the technologies, on the other side the testing environment for solutions coming from third parties like yourself to be tested in those environments. And this applies to all 8 challenges that were presented for the first open call. There's another question regarding the role of drones in our challenges. How do we see the role of drones? Do we see a fit for drones in any of the challenges that we have presented? Julian, Alvaro, Eduardo?
We are, as commented, we are open to any possibility. The thing that you need to take into account, because my understanding is that this is something that can be used in the installation part, is that the level of accuracy that we need is quite high. So take into account this, because we are talking about, in some cases, millimeters in the construction space, that we are talking about many meters. Imagine the facade of a building, 50 meters of length, and then you need to install a module in a specific position of this facade with an accuracy of millimeters. If a drone can be used to improve this process, can be taking into account all these requirements. I don't know if Eduardo and Alvaro, if you want to add something else.
No, actually, as you mentioned, like we have established a base framework to work within, but we are open to for more advanced solutions or expanded the knowledge on the field. It actually helps to foster the goals. That's what we are aiming for.
Okay. Any follow-up question to this one? Okay. Then there is a question, can we apply as a single applicant for the 200,000 euros? What is the funding rate? I think this question was posed before the open call eligibility presentation. So yes, only individual applications are eligible for this open call. One SME or one startup should apply with their proposal, and the funding would be up to 200,000 euros for hardware solution for that individual beneficiary. The funding rate is 70%. So 70% for a maximum of 200,000 euros for hardware solution, and 30% co-financing for a total budget of around 260,000 euros. So total funding maximum 200,000 euros. So that is 70% financed by the project and 30% co-financed total budget of the proposal. Then the question for challenge 4, will there be data sets available for challenge 4? Yeah, I think that's TECNALIA, challenge 4.
I know Nerea is still here.
I don't see her. So challenge 4 is advanced inspection and control systems.
Yes. No, take into account that the idea of this collaboration is that we share with you some of the data that is going to be used for the different processes. So if we have these data sets and they are useful for your activity, we will share with you because at the end the idea is to have this collaboration in order to have the final product available.
Okay, thank you. There was a question regarding challenge 1. Are the digital twins already set up, or can we develop ones on our own? And Alice replied to that before in the chat. And digital twins are going to be set up in the project by AMALTEA Consortium. Any follow-up questions? Okay. Moving on to another question that we got here is, I am the co-founder. Is it possible to arrange meeting or a call to explore potential synergies? If there is an interest to participate in the open call, please submit a question. If you have a clear question about your proposal, please submit it to the help desk or just email us through the contact form. And if there is a need for a meeting, we can enable that, but only if there is something very particular that we cannot address in the open call documents or the Q&A that we are going to keep live for the duration of the project, of the call, sorry. There's another question. Can a university apply or be part of a consortium with an SME? The answer is no. Only SMEs, including startups, individual applicants are eligible for this first open call, and actually for the second one as well, but we are keeping it to the first call right now. Another question that I see here, who owns the IP? Does it need to be open source? The entry IP for TRL3, which is the minimum TRL to join the project, remains with the applicant SME. Whatever may be developed throughout the life of the project, of the support program, be it 9 months or 12 months, will be considered individually between the project partner and the beneficiary. And that will be part of the conditions that you are going to see in the sub-grant agreement that is available together with the package of documents. So the short question is, whatever IP you bring into the project, if you are selected as a beneficiary in the first month of the project, that remains with you, the beneficiary, the SME. Whatever is developed, if there is a joint development with the project partners, that will be an individual case to be assessed. Or if it's open source, it will remain open source if it is decided like that between the company, the selected beneficiary, and the project partner. Would you like to add something to that, Julian or Alvaro?
No. Also take into account that the idea of the project is that the companies obtain benefits of the different activities and that we change in some way the way that we are working here. So, okay, this is something that, as Anka has commented, we need to comment case by case, but in this case, we are more or less open.
I believe that was the last question I saw in the chat, in the Q&A. Anyone else would like to address a question live? We are still here for a few more minutes. Okay, if it's not the case, we would like to thank you all again for being with us today. We hope this has given you some information, something to think about over the summer. And we hope to see you in August, end of August, with the first proposals that are going to be part of the evaluation process of AMALTEA and subsequently to the support program, join the support program. I'm sorry, I was reading another question. Can two SMEs participate together? No individual SMEs have to participate in this open call. We do not accept applications from teams or consortia of any two entities or more. They have to be individual applicants. You have the support of all of us, so don't be afraid. You're not going to be alone, even if you participate by yourself. And you can always count on us for support during the open call with the application process, whatever details you may need or whatever information you are not clear about or you'd like to further get insights, you can always contact with us and we are there for the support, for supporting you.